Hello guys, welcome to my tutorials. Today we are going to simulate the short transmission line, and this is the problem statement. We have 220 kV 60 Hz three-phase transmission line of a 50 kilometer length, and resistance per phase is 0.15 ohms per kilometer. Inductance per phase is 1.3263 millihenries per kilometer, and the shunt capacity is negligible in the short transmission line model. So, considering the load of a 381 millivolt ampere at 0.8 power factor lagging at 220 kilovolt. Okay, these details we will consider. Okay, this is the 381 megavolt ampere at a 0.8 power factor lagging at a 220 kilovolt. So considering these parameters, we will design the short transmission line in a MATLAB Simulink. Open the MATLAB and go to new. And create a Simulink model. So click on blank model. Here we'll get the new model in a Simulink. So to add the elements, you go to library browser. So to add the elements, the SimScape model. In this SimScape, go to power system, go to specialized technology, fundamental blocks, in electrical source. We have the three-phase source over here. Right click and add to the model. Yes. So double tap. And here we'll get the face-to-face RMS voltage. Here we can see the calculated sending end voltage is at 250 kilovolt. So the same values we are going to add over here. 250 kilovolt, and the frequency given is 60 hertz, and we are not performing any short circuit calculation and all, so we will neglect the internal impedance. Apply and click OK. Here we have configured the source. Here we have to measure the so go to back and go to measurements, and here we will find the three-phase VR measurements. So right click and add to the block. Simply you have to connect them. Simply we are monitoring the voltage and current over using this measurement block. Double click on the measuring device, and here we will find the, if we want to measure the face to face, so we can select this also, but right now we are measuring face to face, and also the current measurement we are going to measure, yes. So click on apply and OK. Here also we need to add the resistance and the inductance provided by the short transmission line from the elements. So simply Select the three-phase RLC branch. Just connect them to the meters, after meters, and here double click on this run RLC branch. As we are neglecting the capacitance, so we have to get the RL branch over here. And from the calculations, you can see here the resistance is given 0.15 ohm per phase per kilometer. So to calculate for the 40 kilometer is a 6 ohm. So inductance will be 0.053052, that is a 53.052 millihenries. So we can put the same values here. So resistance is 6 ohms and inductance is 53.052 e to the power of minus 3, or you can give the direct value also, like in henries 0.053052 henries. Okay, apply and click OK. So now we configure the short transmission line inductance and resistance provided by the conductors. So next will be, so again here we have to measure the receiving end voltage also. So we need a one more block of this measuring block. So directly we can connect these terminal. Also you need a load. We need a load, and here we'll get the three-phase load. Just by pressing a Control R, we can rotate this. So now what we have to do, double click on the block. Here we get the receiving end voltage. We know that 220 e to the power of 3, that is the 220 kilovolt, 60 hertz. And active power and reactive power we have calculated, and the capacitance as we have neglected, we can put it 0. Like here we can see the active power is 304.8 megawatt and 228.6 MVAR, that is the reactive power. Here we can add V0 4.8 e to the power of 6. That is the exponential 6, and that is active power, and reactive power is 228.6. Okay, e to the power of 6, and apply and click OK. That's how we have configured the receiving end load. Now we'll move to the next step. The receiving end voltage and current. As we know, the meters are measured in RMS value. So first of all, we'll go to the model library and in measurements. In fundamental blocks, go to measurements. Here, if we check with the RMS value, capital RMS, we'll get this RMS. Go to specialized technology in fundamental blocks. You can see the measurements. Not even. And specialized technology, control and measurements. In control and measurements, in measurement block, we'll get the RMS block over here. So we have added that. So what we can do, we'll take this block, place over here, and click on the block to connect. Also, we need a display to measure. Now search the display. So here we got the display. Simply connect this one to the display. Similar to this, we need to measure the current. So keep this and connect this one to the current. So to test this one, we can run and we can check the values for now. Okay, one more thing, power GUI is the most important block in this. So that we have to add like in a fundamental block. Here we'll find the power GUI. This is the controller, like whatever graphical user interface, like drawings and all we are using for the simulation purpose. That for that purpose, the um, power GUI is very important. So also we know that we have configured everything. So we'll try to run this one. So now we are getting the values over here. So what we can do, we are getting the three values for each because three phases are there. So to make sure it should display all the values, just expand this display to show all the three values. So here we are getting all three values over here. So one more thing that in RMS value, initial value you have to keep it to 0 and frequency as we know it is 60 Hertz. So these things bring some difference during the measurements. So you can see the measurements like 1,000 amperes, that is a receiving end. Slight different values we may get. Uh, Here we got 1,000 and 1.44. That is a 144. Let's see, 144 kV. We are getting exponential 5. That means 144 kilovolt. Yeah, it's almost equal. So now to make the same arrangement at the receiving end, what we can do, we can copy all these blocks, paste it, and simply connect them to with these terminals. And here, if we check the value 126.9, that is almost equal to 127. So that is the calculated value over here, that is 127.06 kilovolt. So now let's move to the next session. So now to measure the power, reactive power and active power, go to library. Here this power sequence measurement block we need. So this will take, so here VABC I will connect to the V terminal and IABC I will connect to the I block. Okay, same thing to measure the power, active and reactive power. So we need two measurement blocks. Just simply copy paste it. Here, here we can compare the value, that is sending and active power and reactive power, 322 and 288. So sending end 322.8 and 288 reactive power. So these values are matching. And we have to measure the apparent power here. So for that, we'll use the multiply math operation. In Simulink math operation, we can get the multiply, that is the product. Just add them. And sum of elements. So also I agree that in this video I'm recreating the reference of YouTube channel videos. So V into I here, voltage and current, and we have to add all these three phase voltages and current. This will be the summation of all three. So here we'll connect the display. This will be the apparent power. 432 MVA. So let's check the. So as we know, we have to repeat all with the receiving end voltage also. So what we'll do, we'll delete all these elements. and we'll copy all these blocks, it and paste them. So we'll move them to the next level and just simply we'll connect these blocks here. Here. So now let's move to the next step. Here we can see the sending end, active and reactive power. So receiving end active and reactive power 304.8 and 322. 304.8 and the same value we are getting here. So next step will be, so now to get the voltage regulation, we have to get the only one result, like we can use the demux, that is demultiplexer. Since the commonly used blocks, we get this, copy this, or adding block, copy paste and rotate. So here, so double tap on this. We have a number of inputs 3, apply and click OK. Here also we'll be having 3 inputs, so make it 3, and this is the voltage. So here V S and V R. Okay, and subtract block we need Vs minus Vr divided by, and here we can get the math operations. Subtract block we need gain also we need, and the divide block also we need. So basically what we'll do, first Vs minus Vr will do, Vs minus Vr that we get one value over here, Vs minus Vr divided by Vr. Again what we can do, so Vs minus Vr we got here, then divided by Vr, and gain block we'll use multiplied by 100. So double tap on the gain, and what is the value? You have to multiply it by 100 and to display the value again here, copy paste the display and connect it to the display and run the simulation and check the result. So 13.6 we are getting in result over here. 13.6 is the voltage regulation. Now to check the efficiency, receiving in power divided by sending in power, multiply by 100, that is the value. So here this 94.4 we need to get the value over here. So since similarly we'll use all these three blocks over here, copy paste. Okay, now we are getting here P receiving in power divided by sending in power. Okay, sending in power again multiply by 100 and display the value. So let's check the simulation. 94.43. This is the value. This is the 0.48 and 94.43 is the efficiency. So let's check the results here. 13.6 and 94.4. 13.48. This may vary like we keep on running. We may get the different values in bit. 0.43 is the efficiency. 94.4. This is the efficiency. Thank you guys. Thank you for watching and don't forget to like, share and subscribe to my channel and try to use the same library where I have shown and in the display if you go in view like a zoom fit to view so we can see all this value and this file I'm going to attach in my below link and kindly subscribe. Thank you for watching.